This video will be mainly talking about the angle bisector. We've talked about angle bisectors before, but now we're mainly looking at them within triangles and other properties with angle bisectors. So just to review, an angle bisector is a ray that divides an angle into two congruent angles. So you can see that in this shape, I've highlighted the ray in red that splits the angle into two congruent angles. Now for measuring the distance from a point to a line, let's say we wanted to find the distance between W to the line. We're always talking about a perpendicular segment. So this line, if we're talking about the distance, it's always going to be the line that's directly towards it, and it'll make a perpendicular intersection with it. So you'll see a video that I have created showing you how to construct an angle bisector on paper, and also a property that we will be mainly focusing on. Alright, on this part of the notes, they're asking us to create an angle bisector construction on paper. So again, just like the perpendicular bisector, we're going to need a ruler, we're going to need a pen, and we're going to need a piece of paper. So go ahead and pause the video and find those, and come back with your tools. Okay, hopefully you paused the video and you were able to find all these tools. So we're going to go through each of these steps again to figure out how to construct an angle bisector. Okay. So first they're asking us to draw a large acute angle. So something that's big enough so that we can draw some extra stuff into it. And we're going to label it PQR. So I'm going to put down my 3 points, PQR. Okay, it's still acute if I drew it, but it's nice and wide so I can add something in the middle. Alright, I'm going to create my angle by extending these two lines out. And I'm going to label it PQR. So PQR, making sure that Q is the vertex of our angle. Again, we're going to fold just like we did the perpendicular bisector, but we're going to make sure we line up these two sides of our angle. So again, it might be beneficial to go over it one more time so you can have a darker line to look for. And we're going to fold it and make sure that these two lines match up. Alright, so let's see how that looks. We're going to fold it. So you should see that line, and you can see that there's a line right below it. Okay. Now, making sure that we line up with with our angle, right? So we're going to line up right at the angle, okay, right at the vertex, and I'm going to just turn it a little bit so that it lines up. So you can see that it's not lined up, and now it lines up with my line on the bottom. Okay. Making sure again we start this crease right at the vertex of our angle, and we're going to crease this line down. So again, things to remember: you want to crease right at the vertex of the angle, and you're going to rotate it and pivot so that it hopefully creases down along the line. Okay. So mine was just slightly off, but you can see that I was trying to go through this vertex, and I was trying to line up my sides together. Okay. We're going to unfold the paper and draw this ray. So this crease here is a ray going straight through my angle. Okay. So this ray is going to be the angle bisector. We talked about angle bisector before. It's when this line splits the angle into two congruent angles. Okay. I'm going to place a point A somewhere on my angle bisector. Okay, so we'll say that's A right there. And we want to draw now perpendicular lines from this point to each of these sides of the triangle. Okay, so I'll show you how to do this. So we're going to fold again. Now, instead of trying to line up this line, we're going to try to fold this line on top of this line, making sure that the crease goes through my point A. So I'm going to hold it right there so that I know my crease is going to go along point A. And I'm going to fold it over. And you're going to see that I want this line here to line up with itself. So I'm going to crease it right at A again. And I'm going to line it up so you can see that I want this line to line up with the side that I just overlapped right there. Okay, and I'm going to make my crease. So what we just did is we just made a line that's perpendicular to this line here. So if I drew the line with the crease, you can see that this line looks perpendicular to the side of my angle. And we're going to do the same thing for from A to this line. Okay. So again, so flipping it over, I'm going to hold it right at A so that I know it'll crease right there. I'm going to fold my paper over, and I'm going to make sure that my line here lines up with itself. I'm just going to move it over slightly, and spin it, and so you can see that now this line matches up with itself. Okay, making sure that we are still crossing over A. And I'm going to crease. Okay, so you can see that now it's creased on A, and I also have this line that is perpendicular. Okay, so we just finished that. It says we need to label this as S and T. So this is S, and our new point here is T. Measure the lengths that we just created, so AS and AT. Let's see how they compare to each other. Now mine was just a slightly off, but it should be somewhat close to what we want. So I'm going to measure this, and it looks like it's around 2.5. Let's see what AT would be. So AT, looking at this length, this is also actually 2.5, so we actually got it pretty dialed in there. Okay, 2.5, 2.5. So what does this mean? This means that if I choose any point on this line, okay, any point, and I'm trying to measure the distance, the direct distance to each of these sides, they will always be equal. Okay. Now the key point is, or part that it has to be true, is these have to be perpendicular, and these will always be equal or congruent. So that's a property of an angle bisector, and we're going to look more into this in some example problems in our notes. Alright, so we just constructed that angle bisector on paper, and we were able to see some properties. So just to review, we talked about measuring the distance between the ray in the middle to each of the sides of the angle, and you were able to see that they had the same measurements. So let's fill out this angle bisector theorem that we kind of explored in that little activity. So if a point is on the angle bisector of an angle, so let's say D here is on the angle bisector, then it is equidistant. We talked about equidistant before. It is equidistant from the two sides. of the angle. So if this is an angle bisector, this point will be the same distance from each side. So BD will be equal to DC. Alright, so let's kind of apply this in an example. So is there enough information to find the value of x? So looking at this first problem, we can see that the only thing given really is 27, 27, and that you have 15 on one side and you want to find x. Now, because we can see that 27 and 27 are congruent here, this means that this line is an angle bisector. And if it's an angle bisector, that means any point here, okay, if I figure out the distance from to each side of the angles, they will be the same. So if this is 15, x will have to be 15. Okay. And this is true because these are perpendicular to the sides. If they were both not perpendicular, this is not enough information. So this is yes. The large angle is being bisected. And you can see that by looking at the degrees. So it's 27 degrees each. Okay? So x will have to be 15.